We're back, and just here's some examples. The difference between achieve and merit. Achieve problems for the distance formula, which we did earlier. Distance formula. Good special effects there. These are strictly, I call them plug and chug type of problems, or substitution. So the first thing you're going to do with your two coordinates, your 2 points, is just label them x1, y1, and x2, y2. Okay, of course those are not going to be given on the test, but if you label those correctly, there's not going to be many mistakes when you substitute them in. There's a lot of negative signs and a lot of brackets and all of that, but we can cope with that. Okay, we can. We have technology to do that for us. So we have a big long square root symbol, and here's where your calculator matters. Like I said, the newer Casio inserts brackets for you under the square root sign, and the older one does not. Okay, so you're gonna have to deal with that, and you're also gonna have to deal with subtracting a negative and not missing out a negative sign. So the distance here is, again, for now, we're going to have this in front of us, and that's what we're using. X2 is minus 3.4 minus the negative 8.5 squared. So that's the subtracting the negative thing that's easy to miss. Okay, don't forget you're subtracting a negative 8.5, not just minus 8.5. All right, distance formula, there's a plus in between there, because we are figuring out, well, technically, like the hypotenuse. Okay, y2 minus y1 squared. Okay, and from here, we enter all of this onto our calculator correctly, and we think about our answer when we get our calculator. Obviously, we're not going to get any negative answers because we're dealing with distance here. So let's pause it and see what we get. So we're back, and if you inputted it correctly on the new calculator, you know that, like I said, it extends the square root sign. We get 9.7183368 something, and units are left out of it for today. And if it's rounded correctly, we should get 9.57. Okay, and Bryce asked this part right here: when you subtract a negative, isn't that the same as just adding it? Of course, it is. Of course. So, if you want to enter just plus that on the calculator, negative 3.4, and instead of doing the minus and negative and just make a plus out of that, that is fine. That's completely correct. Don't do it here, of course, but here is good. Okay? So we'll move over to the merit type, and notice the merit has that word prove, and we'll take a look at what we have to do there. What are they asking us here? Well, so why this is a merit problem is it's just more steps, and we need to know what isosceles means. We need to see that we need to find these three lengths of the triangle, and when we label sides of a triangle, it kind of helps if they're in alphabetical order, so we don't get mixed up. AB, BC, and AC. And see if two of those distances are, in fact, equal. And if they are, therefore, it's an isosceles triangle. Okay? So it's just distance formula 3 times. Kind of time consuming. So let's see what we get for that. AB is 4.12 to 2 decimal places. Okay, we're going to give that an orange highlight because Okay, and now let's try BC. Okay, so do that. Remember with BC, this is x1, y1, and this is x2, y2. Okay, so we got lucky, and the first two sides we tried, AB and BC, are in fact equal. So I don't care about AC, because an isosceles means two sides are equal.
Yeah, but what if it turns out to be an equilateral?
An equilateral is okay, because an isosceles can mean at least two sides equal. Good question. One of those tricky things. If I have at least two equal, means it's isosceles. So I write AB equals BC. That little symbol there means therefore, and you write it in proofs and cool conclusions. Triangle ABC is hard word to spell now. Isosceles. Finished with the stamp of approval. Okay, good job. See you next time.